Greetings, math fans. All right, so this is day 8, and basically what we're doing today is something called scientific notation. Okay, and scientific notation is actually used a lot in science, in engineering, but it's used to describe really big numbers or really small numbers. Okay, so an example, couple random things. The distance from the Earth to the Moon is 92,960,000 miles. That's the distance from the Sun to the Earth. Okay, if I say that's in feet, it's 490 billion 828,800,000 feet. In inches, so it's billion. In inches, it's 5,889,945,600,000 inches. You're like, God, it's huge. Okay, so we can keep going, right? I can say the distance from the Earth to the nearest star is something called a light year. So it's 4.24 light years. And basically a light year, just kind of interesting thing. A light year is how long, basically is the distance that it would take this going the speed of light. How long would it take? So in other words, if something's 4.24 light years away, that means it would take you, this is how far it is. If you travel at the speed of light for 4.24 years, you would get to that location. Okay? And if you actually put that in miles, it's it's actually 5, sorry. It's 5,879,000,000,000 roughly. So that's billion, million, thousand, and there you go. So that is the distance in miles. So what I'm trying to say is, you see these huge numbers. That one last thing, it's estimated the width of the universe. The width of the universe is this distance. Watch this. 550, comma 000, comma 000, comma 000, comma 000, comma 000, comma 000, what? And comma 000. Okay? So that's the estimated, and that's miles. Whoa. That's the estimated distance of the width of the universe. Well, I don't know who measured that. Maybe they went to Home Depot and got a huge yardstick. I don't know. Okay. But, so this first part here is hundreds, and this is thousands, millions, billions, trillions, quadrillions, quintillions, and they call this sextillion. So 550 sextillion miles away. That's pretty far. Okay. You don't walk that far to school. Okay, so anyway, it's really far. So once again, it's a huge number. Okay, how about like a really small number? The width of a hair. Width of a hair is 0.00254 inches. So that's really small. Width of a hair. And an atom is something that everything is made up of. Okay, very small. That's 4 billionths of an inch. So that is 0.0000004 inches. That is 4 billionths of an inch. So that's the width of an atom. So here's the deal. We need to have some way to talk about these numbers and actually to write them. Because I'm sorry, if you're going to try to do some calculation with this, every time you're going to write it out, you got to write 550 and like 20 zeros after that, and it's brutal. Okay, this is where we use scientific notation. I know I've taken like 5 minutes of your time, but I think it was kind of interesting to talk about some of that stuff. So basically, scientific notation. Let me write this out here again. Scientific notation. Okay, it's a way to express large and small numbers. Okay, large and small numbers. So let me just start out with some examples. 523, if I want to express that in scientific notation, this is what I do. It's 5.23 times 10 to the second power. So this is what I'm doing here, math fans. You need to put your decimal place here. So when I start at 523, I basically need the decimal starts here, okay, and then it moves over 2 places. So it's 5.23. The decimal is always here, always after a first non-zero number. Okay, I don't care what it is, but non-zero number. And then I moved it over 2 places, and that's why that number is 2. And it's always times 10 to something to that power. Okay, so let me just do another example. If I said like 8 million. Right now, I need the decimals here. I need to move it over 1, 2, 3, 4, 5, 6 places. If I move it over 6 places, the number becomes 8 times 10. Because remember, I don't care if you put a decimal here, 8.0 or 8 times 10. I moved over 6 places times 10 to the 6th, and that's your answer. Okay, 2,350. All right, well, this decimal starts here, and how many places? I'm going to move it over 1, 2, 3 places. So that's 2.35 times 10 to the third power. Okay? So basically what you're doing, if you kind of want to look at it one way here, because I'm going to do small numbers as well. You're making this number smaller. I'm going from 2,350 to 2.35, so I'm making it smaller. So I'm balancing that out by making this number larger, the exponent larger. Okay? All right, so that's a big number, putting in scientific notation. Let's do a smaller number now. So these are small numbers. Let's do James Bond. 007. Okay. What I'm going to do is, again, it needs to be moved over 1, 2, 3 places because I need it to be after the first non-zero digit. So if I move it over, it becomes 7, and you could say 7.0 if you want. 7 times 10. And I moved it over 1, 2, 3 places, so it's 10 to the negative third power. So small numbers give you a negative exponent. Okay, so if I do 0.000023, that means I move it over, well, I'm over here, so I'm going to go 1, 2, 3, 4, 5. Okay, so I moved over 5 places, so it's going to be 2.3 times 10 to the negative 5th power. All right, so the number of decimal places I move over, it's negative because, again, what I'm doing, I'm kind of balancing this out. Do you guys agree this 0.00023, this is a really small number? So what I'm doing, here, let me erase this, but I'm making it larger. Right, I'm going from 0.00023 to 2.3, so I'm making it larger, and I have to compensate by making this smaller. Kind of balances it out. Okay, so negative exponents, if it's a negative exponent, that's a small number. Okay, so let me just let me give you some rules here, and then just do an example of each one. Okay, first of all, the rule, as I told you already, it's always going to be some number. This is scientific notation. I'm going to abbreviate it, scientific notation, SN. Say it's some number, whatever it is, point, and the rest of the numbers. It has to be after the first non-zero digit. So if you give me a final answer of 23 point something, or 0.23 something. Boo, that's wrong. Okay, it's got to be 2.31. So some number here, and then whatever is over here, it doesn't really matter. Okay, but that decimal has to be after the first non-zero digit. Basically, it's the second location. First location is the number, second location is the decimal. Okay? So that's really what scientific notation is. It's describing really, really, really big numbers or really, really, really small numbers and turning them into scientific notation. So let's do a couple of more examples here with you guys. Okay, so if I had 8,921 and I want to write that in scientific notation, I move it over. Again, it doesn't hurt to just to put a decimal here right away and say, let's see, 1, 2, 3 places. So the answer is 8.921, because the decimal has to be after the non-zero digit, times 10 to the, well, I made this, it was a big number, so that means this is a positive exponent. So I moved it over 3 places. So that's the answer. Okay. 0.056. Well, how many places am I going to move it over? It's right here now, so I'm going to move it over 1, 2 places. That's it. I just moved over 2. So I move it over 2 places. That means you're going to get 5.6 times 10. I moved it over 2 places. It's a small number, so it's the -2 power. Okay? So that's not bad. All right, let's just do a couple simple ones which sometimes throw people off. If I said 6.2 and I asked you to write that in scientific notation, well, how many places are you going to move the decimal over? Well, it's in the right spot, isn't it? So I'm not going to move it over any. So if I want to put this in scientific notation, it's 6.2 times 10 to the, I didn't move it over. No, I moved over 0 places to the 0 power. Which is interesting, math fans, because what is 10 to the 0 power? What is anything to the 0 power? Isn't it 1? And what's 6.2 times 1? Hey, 6.2, which is what we started with. Okay? What about if I did, 80, and I asked you to put that in scientific notation? Well, it's easy. 8.0, I moved it over 1 decimal place. Again, it's a big number, times 10 to the first power. Okay? 0.8. Well, I move it over 1 place. I made it, it's a small number, so I'm making it bigger. So again, it's 8.0 times 10 to that. I moved it over 1 place, a small number, so it's to the -1 power. Okay? So that's converting to scientific notation. Let's go the other way around. Let's convert from scientific notation to standard. So really, all the numbers you see, when you see like 8,256, that we call that standard notation. And 8.256 is times 10 to the, let's move over 1, 2, 3, is scientific notation. Okay, so we've done everything where we've started in standard and we went to scientific. Let's go the other way around now. So we want to go from scientific to standard, and that's just as easy. So in other words, if I gave you 5.67 times 10 to the 4th power, that means, and if this helps, sometimes you need to put some zeros in there. So watch this. I'm going to write 5. And I'm going to put just the decimal here, 5.67, and I'm going to put some zeros here. And then I'm going to move 4 places over. So 1, 2, 3, 4. The decimal really goes there. So I can really, my answer to this problem is 56700. So 56,700. Okay, and I just ignore the other 0. But I just kind of put it in there to kind of help move decimals. Otherwise, if you don't have zeros in there, then it's hard to like move over. Okay, all right, let's do another one here. 9.41 times 10 to the 7th power. Okay, so let's write out 9.41, and I got to have some zeros here, So it's 7 places over, so I'm going to have to put at least 5 zeros. 1, 2, 3, 4, 5. And even if you put a couple extra, I don't care. Do that and then move it over. So 7 places. 1, 2, 3, 4, 5, 6, 7. There we go. So these are out of here. So my answer is 941,000,000. So there it is. 94,100,000. Okay. All right, cool. So let's do one small one now. How about 2.57 times 10 to the negative 4th power? So that's going to be a small number. So I'm going to write 2.57, and I'm going to put zeros on this side. And I don't care. Put some extra ones in there. Who cares? I'm going to move over 4 places. 1, 2, 3, 4. That's my decimal. So my answer to this problem is 0.000257. It's easy. Really easy. Just negative exponents make smaller, positive exponents make bigger. That's easy. So one more, and then we let's do some computations here, some multiplying and dividing. Okay. So if I do 3.14 times 10 to the negative 8th power. Okay. So I'm going to write 3.14 here, and I know I got to put zeros on this side. So, you know, it's 8, but it's not necessarily, you don't have to put 8. I'm just going to put like 8 or 10, doesn't matter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Whatever. Okay, so let's move things over. 1, 2, 3, 4, 5, 6, 7, 8. So just to kind of give you an idea, I know I wrote like, I think I wrote 11 or 8, 10 zeros, I don't know. But notice how many zeros there really are. One, if I count them, 1, 2, 3, 4, 5, 6, 7, and then it's that one other digit because that's not a zero, but I moved it over that many decimal places, and I had to add 7 zeros. So my final answer for this one was point and then 7 zeros. 1, 2, 3, 4, 5, 6, 7, 3, 1, 4. Okay, because if I would put it back to standard notation, I would move it over 1, 2, 3, 4, 5, 6, 7, 8 places. So there you go. That's your negative 8. Okay? It's not bad, right? So that's going between standard and scientific notation. Okay. Let's talk about a little bit about multiplying now. We're going to do multiplying and dividing. So multiplying. If I give you guys 2 times 10 to the 5th power times 3 times 10 to the 4th power. Well, here's what we're doing, math fans. You're taking the 2 and the 3 and you're multiplying together. So 2 times 3 is 6. And you're really taking the 10 to the 5th and the 10 to the 4th, multiplying together. So 10 to the 5th times 10 to the 4th. Okay, and you multiply those guys together. Remember, that's just 10 to the, remember you add these together. So it's 10 to the 9th. Okay, so my answer for this problem that I just drew out here is 6 times 10 to the 9th power. Okay, it's easy. So again, you're multiplying the numbers in front, and then these are your exponents. There's always 10 to the something, and you're adding those exponents together. So 5 and 4 is 9. Okay? Right, let's try another one here. This one's a little, well, before we get into a trickier one, let's do this one. So 4 times 10 to the negative 6th and 2 times 10 to the 8th. All right, so again, 4 times 2 is 8, and I multiply those together, so I'm really adding them, so it's 8 times 10 to the 2nd power. Negative 6 plus 8, put it in your calculator, I don't care. And so we got 8 times 10 to the 2nd power. Not bad. So this next one's a little trickier. Okay, it's 6 times 10 to the 8th times 4 times 10 to the 3rd power. So we're going to do 6 times 4 is 24. And 10 to the 8th times 10 to the 3rd is 10 to the 11th. So now you look at this and you say, well, 24 times 10 to the 11th. Well, what's wrong with that? Well, of course, it's not truly in scientific notation, because scientific notation is actually 2.4. So what I'm going to do is I'm going to move the decimal over. Right now it's right here. I haven't read. And I'm going to move it over one notch. So it's really 2.4 times 10 to the, remember, if you made, this is a big number, so I'm making it smaller. What do you do with this guy? You make it bigger. Okay, you got to increase it by 1 because I moved over 1, so it's to the 12th power. Remember, you always balance it. If you make this smaller, you got to make this side bigger. Same, vice versa, bigger and then smaller. So it's 2.4 times 10 to the 12th is your answer. So again, do not leave it as 24. 24 is not scientific notation. It needs to be 2.4 and then times 10, in this case, times 10 to the 12th. Okay? Very, very, very important. Okay, so let's do one more example like this, and then we'll do division. If I did 7 times 10 to the negative 10th and 8 times 10 to the 6th. Well, 7 times 8, 56. And if I add those together, I get times 10, negative 10 plus 6 is negative 4. So 56 times 10 to the negative 4th. And then I'm going to move it over one decimal place. So it's 5.6 times 10 to the... Now this is where it gets a little tricky, math fans, because you made this smaller, so I have to make this larger. Well, how do you make a negative larger? You have to add 1 to it. A lot of people want to go, oh, to the negative 5, and they put negative 5 there. That's actually making it more negative. That's bad. So you want to add 1 to it, so you get negative 3rd power, so it's 10 to the negative 3rd power. And that's your answer. Okay? Very, very important. So if you're making again that 56 smaller to 5.6, it's a big number, so you're adding 1 to it, so it's times 10 to the negative 3rd power, adding 1 to negative 4. Okay? All right, and then let's do division. So division, if I did 8 times 10 to the 6th over 2 times 10 to the 2nd. Well, that's going to be, you're going to put this in your calculator, because, by the way, in division especially, scientific notation, so SN, never have fractions. Never have fractions. Okay, you'll never have a fraction in the final answer. It's always a decimal. So 8 divided by 2 is 4. And then what do you do when you do division? You subtract these, right? So 6 minus 2 is 4. So it's 4 times 10 to the 4th power. And that's your answer for this problem. But no fractions. No fractions. So what I mean by no fractions is, check this out. What if I did 2 times 10 to the 5th divided by 8 times 10 to the 2nd? Again, please don't tell me 1/4. That doesn't really, that's not scientific notation. You need to do in your calculator, type in 2 divided by 8, and you're going to get 0.25. And then, of course, the 5 minus 2 is 3. So 0.25 times 10 to the 3rd. Okay, this is not in scientific notation. You've got to move it over one notch, so it's 2.5. And I moved over one notch, and again, I made it a bigger number, so I got to balance it out by making this smaller. So you're going to subtract 1, right? Whenever you have a decimal like this, a point something, you always make it the exponent smaller. So it's 3 minus 1, so it's times 10 to the 2nd power. Okay? So let's do one last one here. 1 times 10 to the 3rd divided by 5 times 10 to the 8th. So 1 divided by 5 in your calculator is going to give you 0.2. And 3 minus 8 is negative 5. So 0.2 times 10 to the negative 5th power. Okay, so you need to move it over 1, right? Very important. Move this over to make it 2.0 or 2. I don't care if you put 2.0 times 10. So I'm making it bigger, right? Remember, whenever you have 0.000, you know it's a negative exponent. So I'm making this 0.2, I need to make it bigger, and I compensate by making that smaller. So that means I'm going to subtract 1 from it. Negative 5 minus 1 is negative 6. So times 10 to the negative 6, and that's your answer. Okay, it's really important. So if basically, without doing a whole problem here, if I said 0.17 times 10 to the negative 9th power, you're going to move this over 1 to make it 1.7 times 10 to the, and then subtract 1 from that, so to the 10 to the negative 10th. Okay, if I have 29 times 10 to the negative 8th power, it's a big number, so I'm making it smaller, so 2.9 times 10. So I'm making it smaller, I need to add 1 to it, so it's to the negative 7th power. Okay, so hopefully that's enough practice to help you guys to deal with scientific notation. It's useful in a lot of different sciences, so they call it scientific notation. Okay, so that's it, math fans. That is scientific notation. Hopefully we're good to go. Have an outstanding day. Adios. Goodbye.